Well, hello there, everyone. This is KP the Math G. In our last lesson, we started off with related rates, and I did a couple of examples on some kind of basic related rates. This is a little more to it, actually not more than what we did in the last lesson yesterday. But we do want to examine, I do have a cone one that I'd like to look at, and that's a different specimen altogether. But this one here is, you have to be very careful with this one as well. So that's the reason that I want to present these two questions. The first question is, how fast does the water level drop when a cylindrical, I cannot pronounce words, tank with a radius of 3 meters is drained at a rate of 4 cubic meters per second? Well, when we're doing these problems, these related rate problems, one of the first things that I look for is, is how fast. How fast is something? Okay, that is a rate of change. It could be, all right, in a cylinder, and I'm going to try to draw a small picture of this because we got a lot of math here involved. Okay, right there. All right. The water level here is dropping. Okay, so there is a water level that is dropping. Okay, and we have we have two things basically when we're looking at the cylinder, a right circular cylinder. Okay, and that's the radius and the height. Okay, so when you have things like this, you also have the rate of change of each one of them. That is, in this case, you would have something like dr over dt, and in this case, this is dh. I'll just put it down here, dh over dt. Okay, now this is, and then of course we have volume. Alright, now, and if we have volume, we have also the derivative of volume is dv over dt. Alright, this is a volume of a cylinder, alright, of a right circular cylinder. Okay, so it's asking how fast does the water level drop? The water level is dropping. What is that affecting? Is that affecting the radius, or is that affecting the height? And you got to ask yourself every time, what is being affected here? In this particular case, the height is being affected. So this is what the question is asking for, is how fast does the water level drop? Okay, so that would be dh over dt. That's what we're looking for in this problem. Okay, we have to pay attention. It is a right circular cylinder. Okay, we need to look at that. Is it a cylinder? Is it a conic, or actually a cone? Is it something else? So we have to always look at that and pay close attention to the object here. Alright, it is a radius, alright, of 3 meters. So this is what we're fixing to do. And then of course this rate, anytime we see a rate and I see something cubic, that is going to be dv over dt. That is the rate of the volume. And volume, length, width, and height. Okay, you have 3 dimensions here. So you're going to have a cubic here. This is dV over dt. So if you see that, that's what we're talking about here with here, dV over dt. All right, so keep those things in mind. So let's see, we have the radius already is 3 meters. We have dV over dt. That is going to be 4 cubic meters per second. We already know what those two are. We don't know what H is, and I'll show you in a moment that we don't need to worry about H, the height of this cylinder at all. We'll see that in just a moment. But we are looking at the derivative of this. So, okay, let's look at the volume of a right circular cylinder. You need to know those formulas. Alright, it is pi r squared, the area of a circle, times the height. Some people will go ahead and plug the radius in, since we are looking for dV over dH over dt. They'll go ahead and plug that in, but I'm not going to do that. I'm going to go ahead and take the derivative altogether. Okay, so hopefully we won't have to erase this, but it appears that we may have to. Alright, so let's go ahead and take a look at our derivative. This is a product rule. We're taking these two and then this one. Okay, recognize that. Okay, and we're including pi with r. Pi is a number. Okay. Okay, so let's go ahead. The derivative of v is dv over dt. So if you want to put a 1 there, you can. Derivative of v is 1, dv over dt. Alright, now the first times the derivative of the second. The derivative of h is 1, but that's 1 times dh over dt. That's the very thing that we are looking at. How fast does the water level drop? Okay, that's what we need to find. Alright, well, let's continue with our derivative though. Alright, so we got the first half of the product rule. Now let's do the second half of the product rule. So then we have let's see, this is the first times the derivative of the second. Alright, now we take the derivative of this, which is 2 pi r, okay, dr over dt. Since we took the derivative of the radius, we stack that in with that. Okay, that needs to go. Every time you take a derivative of a variable, it's that thing, dr over dt, dh over dt. Alright, now times the height. Okay, and that is the derivative right there. We are going to look a little bit at dr over dt in just a moment, and that's what we're going to look at and hone in on, and we'll see what happens there. Okay, let's keep going with this problem here. dV at 1 times, okay, dV over dt, we already know that is 4, and I'm going to put the units on later. So 1 times 4 is 4. Alright, pi, we know that the radius is 3, so 3 squared, and then times dh. 1 times dh over dt is dh over dt. Okay, like that, plus 2 pi r, which is again 3. Alright, dr over dt, and then times h. Well, we don't know how high it is. Okay, we weren't told anything about the height, but we are saved here because dr over dt. Let's think about this just for a little bit. And let me move this. Let me step myself out of the way. The radius at any height, does that ever change? It's going to drain down. Okay, so if this radius were 10 meters, then this is also 10 meters. Okay, then this one also, even after it drains completely out, the radius does not change at all. So the radius is not changing. It's not going in and out. The thing that's being affected, that's going down, is the height. That's what's being affected. The radius is not at all being affected. So look right here. This answer is 0. Now, calculus students, what is this answer here? You know it. Don't think about it. It's a no-brainer. All of this is 0. Okay, now I'm going to finish the problem then. Now that I know that, and some people will say, even some teachers will leave this part out. You plug the 1 in from the start right up here, or actually in this case 3. You figure out what that is, and then you would have 3 squared is 9, and then 9 pi h is what you would have. It would be a little simpler, but I wanted to go ahead and do this. It'll say you didn't think to put that in from the start. And some teachers try to teach, do not put anything in until you take the derivative. Well, that's what I just did. Now, right here, we have 3 squared is 9. So that's what we had. That's what you would have had in the first place. So 4 is equal to 3 squared is 9. Let's put that in front of the pi. So 9 pi, okay, dh over dt. And remember, this is plus 0, so we really don't need the plus 0 there. Okay, but just for emphasis, I'll just put that there. Now I just need to solve for dh over dt. Okay, so I'm just going to divide both sides by 9 pi. And lo and behold, dh over, and by the way, I made a mistake. You know what I made? This is drained at a rate. It's going down, it's draining at this rate. And this means if it's draining, if it's going down, if the water level is dropping, then we have to make this negative, which means that this 4 is negative. Now, why is the answer negative? So let's see, this is negative 4 over 9 pi is equal to dh over dt. This simply means that the water level is dropping. There's your negative sign right there. It's dropping at a rate of 4 over 9 pi. So if you write it out, if you have to write it out, you can say the water level is dropping at a rate of negative. Oh, whoa! It's not negative. 4 over 9 pi meters per second. Okay. Height is always in meters per second. Volume is in cubic meters per second. So we're at meters per second right here. Okay? So do not put the negative here. You can write it down in the answer here, but when you write the explanation, the dropping here is in place of the negative sign. So you're dropping. So it's dropping down. I already know it's dropping. Okay. All right. So there it is. Okay. And you have to put your units down in this case. All right. That is one of the two problems. Just keep in mind here that the dr over dt is 0 here. Okay. All right. Let's look at the other side. This is an interesting problem. I love this problem, but you have to be extremely careful when you do a problem like this. It is a cone. Okay. So let me see if I can draw a picture of a cone. I'm not a very good artist, but hey, that's pretty good considering. Alright, now R, that's R. That's definitely a radius, and then of course there is a height to this. Okay, right there. Well, maybe a little. Okay, right about there then. Okay. Okay, that's your height. Okay, that's the same thing. But now this time it is tapered off. Okay, so we have a different equation altogether. Let's look at the problem. It says water runs into a conical tank at a rate. So now the water is getting higher and higher. It's not, so we don't have to worry about a negative number here. It's going into a conical tank. It's going in at a rate of, now look at that, cubic feet. Oh, that's dV over dt. So dV over dt is 3. All right, there it is. It's cubic feet per minute. So we know that water is coming in. That is dV over dt. The tank points down. All right, that is. It's pointing down and has a height of 12 feet. So we know that the height is 12 feet. All right. And has a base radius of 4 feet. So 4, so R is equal to 4 feet. Okay, there it is. And that's in feet also. Okay. How fast is the water level rising? So again, in this case, both R and H are being affected here, but we're talking about water level, so that would have to be that we're looking for again, dH over dt. So again, the water level is what we're looking at here. When the water is 6 feet deep. Okay, so when the water is 6 feet deep. Let's look at this problem. Let's look at the formula, or the formula for a cone. Okay, so let's see, it's actually 1/3 pi r squared h. Whereas the right circular cylinder is just pi r squared h. The volume is 1/3 of that if you're talking about a cone. Okay, now, and that's one thing, you just have to remember those things. Okay, now let's take a look here. We're going to come up with a ratio. We see then that the ratio of the radius to the height, the ratio is 4 to 12. 4 to 12. Now we're not worried about this. That's at that moment. That's after we take this derivative and so on. Then we'll plug this specimen in here. We'll plug that number in there. So right now, this is 4 over 12. If you want to reduce this, you can say, well, R over H is, R to H is 1/3. Okay. So if we multiply this, we have 3R. 3R is equal to 1 times H, which is just H, isn't it? Okay, so we don't need the 1 there, do we? We just need the H. Now, the deal is, depending on what we're looking for, if it did ask for the rate of how fast is the radius changing, then we would do dr over dt. So we would have a dr over dt. In this case, we're looking at the water level, and once again, just like the last problem, it is dH over dt. Okay, let's take a look at this. Now, one thing that we can do here is I can make this, since I'm looking for dH over dt, and it's apparent that I'm looking for that because it says water level, I am looking for dH over dt. I'd like to get rid of this R. So one thing that I can do to get rid of the R is just simply solve for the one that you get rid of. So if you want to get rid of R, solve for R. And what you have here is R is equal to H over 3. Now in place of R, I'm going to put H over 3. But remember, I got to square that. So let's do that. So 1/3 pi times R squared, H. R squared is H over 3. And that's one thing that you just have to learn how to do is, okay, when you're looking at a conical tank, you're usually going to have a ratio that you have to deal with. When I worked it out before, I had these flipped over. So make sure that everything corresponds with the radius and with the height. Okay, and it does. Let's finish our problem now. We haven't even took the derivative yet. So here we are. Is V is equal to 1/3 pi. Now if we square the H, we get H squared over 9. 3 squared is 9 times H, and H is H over 1, isn't it? Come on. H over 1. Alright, now H squared times H is H cubed. So now we are at that point. Let's go ahead now and erase this part because we're going to need a little room here to do the problem.